Okay, so we're jumping into a relatively short and arguably simple unit. We're going to kind of squeeze this in before the end of the second quarter because it fits. It's, like I said, relatively short and relatively easy as well. So we're going to be basically just today following some simple rules. Some of these rules you may remember from Algebra 1. You may have seen some of this before. It's not really any problem solving. It's just a set of rules that we need to make sure that we follow. Okay? And there's a rule book. We'll have some guidelines that we'll keep in mind as well. So let's begin with a rational exponent. A rational exponent is an exponent that's expressed as a fraction. So you can see an example over here, like down there, 16, 1/4 power, right? 16 to the 1/4 power. And 8 to the 2/3 power. We're just going to rewrite these in radical form. So write it where we're using a radical, or we can also go backwards and write it from radical form into an exponent form. So we're going to kind of interchange that there. So the rule of thumb is mainly the one that we really need to focus on, since these are basically the same rule, except the top one, n is equal to 1. But we're going to focus mainly on this rule down here. And we'll just follow this set of instructions. So, a to the mn power. The m is the top of the fraction, and it's going to be the exponent when we put it in radical form. And the n is the denominator, right? And it's going to be something called the index. It's going to be the number out here, which basically means the second root, the third root, the fourth root, whichever root that we're taking. We're used to doing square roots. But that number can change. It doesn't have to be square roots. It could be the third root, right? Cube roots, or the fourth root, etc. All right, so let's just rearrange these. I want to write these expressions in exponent form. All right, so eighth root of 8 to the 4th power. Again, my rule was this equals to basically this, right? So it's just sort of rearranging the numbers. So m in this case is the 8, or sorry, the n is the 8, right? And the m is the 4. So if we just want to write it like this, we'll have basically 8 root of 8 to the 4th is going to be equal to a, let's see, 4 is going to be, hold on, go crazy. 4 is going to be the top here, and then 8 is going to be the bottom. Right, so 8 to the 4/8 power, which we can reduce now to simply 8 to the 1/2 power. So that's how we can write it from radical form to an exponent form. All I've basically done, I guess I thought it was going to show me the answer there or not, but okay. All we've basically done was rearrange the numbers into a different format. Okay, we're not solving anything, we're just rearranging them into a different format. So same rule applies to b. We're going to have f to the 15 over 5, which 15 over 5, that's the correct answer. This is a fraction here, but we can reduce that fraction. This is going to be the same thing as f to the 3rd power, right? Because 15 over 5 is 3 over 1. We're just 3. So that's really all it comes down to, at least for the beginning stages of what we're doing today. All right, we're going to try it again for some of these. 4th root of x to the 3rd power. Now notice the exponent is outside the radical. It doesn't matter if it looks like you see it here or if it looks like this, where it's inside the radical. It's still an exponent. It's still sort of meaning the same thing. There's no difference between that. So don't get freaked out if you see that. It's totally normal. But anyway, we're going to write this in exponent form. So it's going to be x to the, remember the power is the numerator and then the index is the denominator. So it's going to be 3 over 4. And that is simplified, that is reduced, so that's the final result there. Okay, again, we're just putting it from one version to a different version. Y to the, again, the power is the numerator and the index is the denominator, so it's 9 over 3, which we can simplify, which is just y to the 3rd power. And then the last one, z to the, remember the power is the numerator and then the index is the denominator. 2 over 4, which is going to be z to the 1/2 power. So if it helps, maybe make a note of it, but your power is going to be your numerator, and your index is equal to your denominator. This is going to be your denominator when you rearrange it. All right. So remember that little trick. It's not problem solving; it's just simple rearranging. All right, but now let's use a little bit more of this. Some other rules and properties we're going to follow. Again, not really problem solving at all. We're just sort of simplifying, putting things in a better version of themselves. And this is our rule book today. If we can just follow these simple rules, we'll be okay. So when you're multiplying powers, we are going to add their exponents. So x to the second times x to the third is x to the fifth, because you're essentially adding the 2 plus 3. Now, why is it you're adding the exponents if you're multiplying the powers? Well, here's the reason. If you have x squared, for instance, right, you have x times x. And if you're multiplying it with x to the third, then you're multiplying it with x times x times x. Which, if you look at it, take a step back, this is x to the fifth power, right? It's x multiplied 5 times. So, the shortcut, the trick is add the exponents. All right, now divide powers. Let's that. Divide powers is we're going to subtract the exponents. So that's if you see x to the fifth over x to the second, we have x to the third. So what you're doing is the 5 minus 2. Remember, this is kind of the numerator minus the denominator. It's not going to be the other way around. You're always going to take the top minus the bottom. And the reason for that, if you're wondering, x to the fifth, 5x is on top, and x to the second, 2x is on the bottom. Well, these x's will cancel out. The x's on the bottom will cancel with a pair from the top. That will cancel with one from the top, and then there's no more left to cancel, so what we're left with, x to the third, which is the reason why basically you're subtracting, because you're canceling out. That's the reason for that. All right, so power raised to another power. We're going to multiply the exponents. So we have x to the second to the third power, which is going to give us total x to the sixth power. So you're actually multiplying these numbers now. 2 times 3. And this is different than the first step, because let's write this out. X squared to the third power means x squared multiplied out 3 times. X squared times x squared times x squared. That's x squared to the third power. But again, if you spell it all out, it's x times x times x times x times x times x, which is, of course, x to the sixth power, since you're multiplying 6 of them together. So power raised to another power, you multiply 2 powers multiplied together, you actually add them. So it's kind of, a lot of people will get those confused. Always come back to this little chart, it'll help you remember. All right, and power of product or quotient, you can distribute that exponent inside. So basically these last two are expanded versions of the one we just talked about. But it only works with products or quotients. It does not work if you have at plus signs or minus signs, some sort of addition or subtracting. You cannot distribute in those cases. You can only distribute if you're multiplying inside those parentheses there, or if you're dividing them. Okay, it does not apply to anything with plus signs or minus signs in those parentheses. You cannot simply distribute those. All right, so you can pause the screen if you want to look at some little examples there of things that they've done, but we're going to just practice these rules a few times. So this is x to the fourth times x to the seventh. Our rule to remember here is that if we're multiplying powers, we add the exponents. So x to the fourth times x to the seventh is x to the 11th power. That's all there is to it. How did I get the 11? Because it's 4 plus 7. Why did I add? Because I was taking x to the fourth times x to the seventh. If I'm multiplying powers, I'm adding their exponents. So the same rule applies to number 2. We're going to have y to the 6th power, because 1 plus 5. All right, now I have a negative in number 3, but that's okay. It's still adding negatives or subtracting. So we'll have z to the 6th and z to the negative third power. We're going to be z to the third power, because it's 6 plus negative 3. Essentially 6 minus 3 is 3. And then the last one, I have a fraction, 7 to 7 over 9, and 7 to 11 over 9. So we're basically adding these together, the 7 over 9 and the 11 over 9, plus 11 over 9. You can add these together as long as they have like denominators, which they do. This would become 7 to the 18 over 9. And we could simplify that fraction because 18 over 9 is 2. So it's really 7 squared, which is, if we fully work this out, 49. My tip to you is if you have a calculator, just type this in your calculator. You should get a good result. Especially if it's multiple choice, you'll see that one of those answers will line up for you. How would you type that in the calculator? Well, my suggestion to you is it would be 7. And then you would do a little arrow up button to get your exponent, and then use parentheses to put 7 divided by 9 in your calculator, and then you can multiply 7, raise the exponent with the little caret key, and then parentheses 11 divided by 9. That gives you the 7 to the 7 over 9 power, and then the 11 over 9 power. All right. Number 2, we're going to divide our powers between to subtract the exponents. Remember, this is always the numerator minus the denominator. All right, so x to the 5th over x squared is going to be x to the 3rd, because 5 minus 2. Y to the 7th over y to the 5th is going to be y squared, because 7 minus 5. Z to the 3rd over z to the 5th is going to be z to the negative 2nd power, because 3 minus 5 is negative 2, but we should really write this as 1 over z to the 2nd power. A little pro tip for you, one that you may recall from Algebra 1, is if you have a negative exponent, it belongs on the other side of the fraction. So if I have a negative exponent, in this case, it's technically in the numerator. You don't really see the over 1 part. Then that exponent really belongs in the denominator, and then you can put it as a positive exponent. So the negative exponent basically tells you it's in the wrong place. Move it to the other part of the fraction. All right, so just keep that in mind. And then our last one, a calculator would be really helpful here. But if you don't have one, we're basically doing 16 3/4 minus 5/4. And 3 minus 5 would be 16 to the negative 2 over 4, which is still at 16 to the negative 1/2. But again, I would write this, basically it's in the wrong side as a negative. If we move to the bottom of the fraction, we would have 1 over 16 to the 1/2 power. Alright. Oop, moving too fast. Alright, power raised to net power, we're going to multiply these exponents. So x to the 3rd to the 5th is really x to the 15, because 3 times 5. Y to the 2nd to the 7 is y to the 14. And then z to the 4th to the negative 1 is z to the negative 4. But again, remember, we move this to the other side of the fraction if we have a negative exponent. Not to the denominator, okay? Yes, all these have been moved to the denominator. That's because all of them have technically been in the numerator the whole time as well. If you have a negative exponent in the denominator, you would move it to the numerator. So you just move it to the other side of the fraction. I know all of these have been moving them to the denominator, but it is still a thing. If, for instance, we ever got a result that was 1 over z to the negative 2nd power like this, then the negative exponent basically means move it to the other side, which you would have z squared at that point. So just keep that in mind. The negative exponents, move it to the other side of the fraction. All right, and now the product of a power, or a power of a product or quotient, you distribute. Again, as long as there's no plus or minus signs, all we need to do is multiply these all together. So this will be x to the 8, because x to the 4th squared is 4 times 2 is 8, and then y to the 6th. We'll have, now this a to the 1, right, a to the 1st power, so that's going to become a to the 3rd, because 1 times 3 is 3. And then b to the 12th is 4 times 3. If we distribute the 5 here, we'll have f to the 10th power, because we're multiplying 2 and 5, over g to the 30th power, because 6 times 5. And then we're distributing this to all pieces as well. So this is going to become x to the 5th squared is going to be x to the 10th, because 5 times 2, y to the 6th, because 3 times 2, and then z to the 8, because 4 times 2. All right, so if you're willing to, kind of take a guess here, you could try some of these problems on your own. That's going to cover it for today. Again, it's a simple rule book. If you go back to your chart at the beginning, this tells you everything basically you need, in addition to that very first one that we looked at, which was, where do you go? Too much. Right here at the bottom. That rule, in addition to these rules, pretty much sum up everything you're going to need. So that's going to cover it. I'll leave you guys with that. We'll see you in the next one. Sayonara.